So today we will start a new chapter, that is acid, base and salt. This is chapter number 2. So first of all we will learn about acid, then base, then salt. Now what is acid? What is acid? This is the first question. What is acid? Now, or how we can identify, or how we can identify acids. Now, first of all, number 1, so test. Number 2, contains hydrogen, and number 3 is turns red litmus turns blue litmus red. So these are the properties or characteristics, you may say, to identify a substance or an element. These 4 properties should be present if a substance is acid. How can you identify an acid? If these 4 properties or characteristics are present, then we can identify an acid. Now we will move on to the classification of acids. How many type of acids are there? How many types of acids are there? Acids classification, there are 2 types, organic, in first half organic, and mineral. Now what is organic acids? Which are generated or produced by plants and animals. And mineral acids, mineral resources, from mineral resources it is generated. This is organic, this is inorganic. So these are the 2 types of acids, mineral acids and organic acids. Again, plants and animals, that means organic, mineral, from mineral resources. Mineral sources. Done, organic and mineral done. Then I will come to minerals. Example. Organic example is, suppose yogurt has lactic acid, then ant has formic acid. These are the example of organic acid. Now these mineral acids have, suppose I will take an example, sulfuric acid. This is a mineral acid. Sulfuric acid, which is written as H2SO4. Where it is used? It is used in car batteries. It is mainly used in car batteries. This is an example of mineral acid. Done. Now we will move on to the next topic of acid, that is acid, Ardenius theory of acid. And one scientist named Ardenius theory of acids. This is a theory you must remember. Ardenius theory of acids. What it is saying, that acids should contain H plus ions in it. When dissolved in water. When dissolved in water. Now suppose I am taking hydrochloric acid, will give you H plus, which is an aqueous solution, plus Cl minus. So criteria matched. We need an H plus ion. It is there in the definition also. So Ardenius theory of acids proved. So this is the definition and example of Ardenius theory of acids. Acids done shortly. Now we will move on to this base. Same question comes to our mind, that what is base, or how we can identify base. How we can identify base. How we can identify base. Now this 4 property or 3 property will identify base. Number 1 is slippery, bitter taste. Number 3 again red litmus, blue. In acid it was red, blue litmus red, and here red litmus will turn to blue. These are the 3 characteristics or properties you can say to identify acid, to identify base. These are the 3 properties. Done. Now what are the uses of base? I will give you one example, that is, I am explaining one by one step, students, so listen very carefully. This is a very important chapter. I will take one base, that is sodium hydroxide. Sodium hydroxide. Sodium hydroxide. Sodium hydroxide, also called caustic soda. Caustic soda. Also called caustic soda. Uses is used in making soaps. Soaps and paper. So this is an example of base. Now we will move on to next, that is again the Ardenius theory for base. Now Ardenius theory of base. Now what is it? First one is, first in acid we have seen we needed H plus ions in what? Acid. But in base we will need OH ions, OH minus ion, that is in base. I will give you one example, that is NaOH will give you Na plus, this is the charge, and OH minus. This is the example. In acid, H plus ions are taken and to dissolve in water, and here OH minus ions are taken to dissolve in water. So this is the example of Ardenius theory of base. So proved OH minus ions are needed. See, now very important question. In boards, this question comes very frequently. Very frequently this question comes, that all alkalis are bases, but all bases are not alkalis. Justify or give reason. This question frequently comes most in boards. So first of all, you need to know what is an alkali. Alkali means this bases which are soluble, bases which dissolve in water. So this is the definition of alkali. Definition of alkali. All alkalis are bases, but all bases are not alkalis. Why? Because all bases are not soluble, means cannot be dissolved in water. All bases are not soluble in water. That means soluble means it doesn't dissolve in water. So this is the reason. That is why all alkalis are bases, but all bases are not alkalis. Now moving on to the next topic, that is indicator, acid base indicator. Indicators. Acid base indicator means how we can indicate that this substance is acid or base. There are two methods. One is natural, and other one is synthetic. In natural, we need litmus, red cabbage, and turmeric. And in synthetic, we need methyl orange, and phenolphthalein. Sorry, I am writing the wrong spelling. Phenolphthalein. This is synthetic, and this is natural, and this is synthetic. Now we will discuss what color they will make in acid and base. We know that in litmus acid becomes red, and in base litmus becomes blue, and in red cabbage red in acid and green in base. Green in base. And turmeric is yellow in acid and reddish brown in base. I am writing here B. In synthetic indicators, methyl orange, this was natural and this is synthetic. Methyl orange, again it is also red in acid. This is also red in acid. Red cabbage is also red in acid and color changes to red in acid in methyl orange also. And yellow in base. Done. Methyl orange done. Phenolphthalein. Red in base. This is red in base and colorless in acid. So we have seen red cabbage, turmeric, methyl orange and phenolphthalein changes color in acid and base. So if you want, you can pause it and write it down. Now we will move on to the next topic, that is olfactory indicators. Olfactory indicators. Now what is olfactory indicators? Odor changes. Odor changes means smell changes in acid and basic. Odor changes in acid and basic. Acidic and basic. Odor changes. Suppose I will give you one example. Smell of onion disappears. In base but remains in acid. This is one example of olfactory indicators. So students, hope you like this video. Please share, comment and subscribe my channel. And if you have any doubt in this part, then let me know in the comment section. Thank you.